Okay, so that worksheet was about graphing from vertex form. So, brief recap, vertex form is a, or y equals a, x minus h squared plus k. Okay, so why is it called vertex form, and why do we like vertex form? That's the same answer to those questions. It gives you the vertex. Right? This is the easy, like the best form for graphing. So x minus h would go right h, plus k would go up k. So it just gives you your vertex pretty much right away. So we like that form. It's great for graphing. Right, because go to the vertex, and then you know the 1, 1, 2, 4, and use the a thing. Which set of coordinates gets the a's? The x's or the y's? The y's, because it's a vertical stretch or compression or flip. We'd multiply the y's by a, and then we'd have it. Like that's what that last worksheet was. That's nice. We like that. I don't know, there's probably a better name for a than the y coordinate multiplier, but that's what it is. So let's just call it that, because that'll do the stretch, the squish, or the flip. Okay, that was all last worksheet. Pretty easy. And yeah, you guys didn't ask any questions on those. All your questions were factoring questions. Today we're going to graph from standard form. Standard form is y equals a, and that's the same a, so that a does the same thing as the previous a does. So like that's the same a. But the rest of the equation looks different. Ax squared plus bx plus c. Like somebody multiplied it all out for us, which is not really what we wanted, because we'd rather it in vertex form. But we can graph it from standard form with the help of a new equation, new this year. First time we've used it this year. The x-coordinate of the vertex is negative b over 2a. I think y'all are familiar with the quadratic formula. I like to talk about it because it gives me a chance to sing, right? Is that how you remember it? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I mean, is that not how you remember that? Like, that's the song. Do you remember what that tells you?
Zeros.
It tells you the zeros. It tells you the zeros, wherever those are. Well, what's always in between the zeros of a parabola?
Vertex.
The vertex. Like, I mean, who knows where it is. It might be way up there, it might be down low, but somewhere directly in between the zeros is the vertex. And in fact, the plus or minus, that's what gets you the on either side of the vertex. So if you go plus a little bit, you go to the right, you go minus a little bit, you go to the left, that gets you your zeros. But if you don't do the plus or minus stuff, that's the x-coordinate of your vertex. So this formula might be new, but it comes from a formula that you already know. So that's the connection between the full thing gives you the zeros, the negative b over 2a gives you the x-coordinate of the vertex. It also happens to be the axis of symmetry. right? Because the axis of symmetry always goes through the vertex. Okay, so that gets you the x-coordinate. When you know the x-coordinate and you want to know the y-coordinate, what do? Plug it in. Plug in x to find y. All right, how about y-intercept? What do you do to find the y-intercept? This is always and forever. Plug in 0 for what? So we'll set x equal to 0, and you get 0, comma. This is the only nice thing about standard form. If you plug in 0 for x, you get c. So standard form is nice for the y-intercept, but that's about it. For the x-intercepts, well, we set y equal to 0. And then we factor, and then set the factors equal to 0, all those things. There's another way to get the x-intercepts. Thanks. You can get them from the graph. So rather than find the x-intercepts and put them on the graph, you can find them from the graph and then just say what they are. If you use the 1, 1, 2, 4, sometimes those land on the x-axis, and you can find them that way. Meaning you can sort of avoid factoring. And then lastly, sometimes there are no x-intercepts. What would have to be true of a parabola for it to have no x-intercepts? Jacob?
For it to be either above or below the x-axis and be facing away from the x-axis.
Okay, yeah. So if your vertex is above and you're going up, then you wouldn't have any x-intercepts. If your vertex is below and you're going down, then no x-intercepts. So occasionally today, you won't have x-intercepts. And it's best if you start graphing first. That way, instead of you setting this thing equal to 0 and trying to factor something that's never going to work, if you start graphing first, you realize, oh, there aren't any x-intercepts. Okay, let's do a few together. So turn the page to this worksheet. This worksheet is also due Friday. Again, we're going to do 3 together, or I'm going to do 3 with you, and then you guys are kind of work together and hopefully finish before you leave. That's my hope anyway. Let's skip ahead to number 6. Oh, I guess let's read the directions first. Identify the vertex, axis of symmetry, y-intercept, x-intercepts, domain, range, and graph. Okay, number 6. Let's go in order here. Let's find the x-coordinate of the vertex. You know what? Before that, let's make sure we understand who A, B, and C are. In Algebra 1, sometimes you got to spend a little bit of time working on who's A, B, and C. No pressure, Jenna. What's A equal to in this? 1. Madison, how about B? 6. Okay, good. This is supposed to be easy, but we just got to make sure we recognize who's who here. Rayanne, how about C? 8. A little country twang in your 8 there. Yeah, so now we can plug B and A. I don't need C yet, but so negative 6 over 2 times 1 would be negative 3. And that negative 3 tells me, it kind of tells me two different things. What's one of the things it tells me? It's the axis of symmetry. I could label that and be done with it. And if I wanted to, you don't have to graph the axis of symmetry. But if you want to, it might be helpful. And then what else does it tell me? The x-coordinate of the vertex, right? And that makes sense. The x-coordinate of the vertex better be on the axis of symmetry or something has gone crazy wrong. So the y-coordinate would be, well, I don't know. Let's plug in negative 3. Oh, look, we get to square negative numbers again and again and again. So that would be 9 minus 18 plus 8. Negative 9 plus 8 is negative 1. So my vertex is negative 3, negative 1. I'm going back to my directions here to make sure I get everything. So I've got vertex, got axis of symmetry. Next up is y-intercept. Y-intercept always has 0 in for x. And this is the only nice part about standard form. If I plug 0 in for x, what do I get for y? C or 8, either one. Yeah, 8. So 0, 8. And then you don't have to do this, but because of the symmetry of the graph, there's only one y-intercept, but it kind of gives you 2 points because you can mirror it across and get another point for your graph, make your graph more accurate. All right, x-intercepts means we set y equal to 0. Wait, I guess we should ask first, are there going to be x-intercepts for this one? Definitely. So let's factor. If you see an easier way, hold on to that thought, because there is an easier way. Factor, and then we set our factors equal to 0. Intercepts are points, so don't just write them as 8 and 4 and 2, like write out the points. So negative 4, 0 and negative 2, 0. And I know doing lots of stuff on one problem is sometimes a pain, but it's also kind of a help because it should all fit together. Like if you factor it and you decide that your x-intercepts are over here, well, hopefully you realize, wait a minute, something is not right. Like, I can't have an axis of symmetry here and x-intercepts over there. And so, usually, students will recognize that something went wrong, and then they got to go figure out, well, did I mess up the axis of symmetry, or did I mess up the x-intercepts? But because there's so much going on, it kind of checks itself. The more information you get, it starts to check itself. Okay, that's all the pieces that I need, so I can graph this. Okay, side note, how else could I have found those x-intercepts? Once I knew where my vertex was. The 1, 1, 2, 4 stuff. Over 1, up 1, lands on the x-axis, so that's an x-intercept. Over 2, up 4. So, right, there's no shame in using what we already know to kind of check what we're learning. So you can do the 1, 1, 2, 4 stuff to sometimes land on the x-axis. Occasionally the 1, 1, 2, 4 doesn't land on the x-axis, and then you've got to do the factoring thing. So it's kind of up to you. 1, 1, 2, 4 is easy, and most of you do it anyway because it gets you some points. So usually you're going to do this first, and if you happen to land on the x-intercepts, then great, you get to avoid factoring. If they don't land on the x-axis, well, then you got to go back and factor. Or you could do both to check and make sure it looks right. There's my picture. Let's see, domain and range. I can definitely call people for domain and range. Grace, how about the domain? Always, yep. Giant, how about the range? Good. -1 to infinity. So, lots of pieces, but again, they sort of self-check as you go. Let's look at number 7. Tell me something you notice about 7. What's that? We said something. What about number 7? What makes it different than the one we just did? It's negative. So I know it's going to be going down. Let's see. So x equals negative b over 2a. All right, why don't you see if you can find the vertex. So find the x-coordinate, and then plug it in to find the y-coordinate. Plug in 0, get -12. Well, that's right, but I suppose you could try to guess where -12 is down here somewhere. But I don't know, that point's so far off the graph that might not be too helpful. Okay, how would you like to find the x-intercepts? Do you want to factor, or do you want to do 1, 1, 2, 4? I would agree. Let's do 1, 1, 2, 4 and see if it lands on the x-axis. If it does, we don't have to factor. We said it was going down, so we can still do 1, 1, 2, 4. Just make sure we're going down with our parabola. So over 1, down 1. Over 2, down 4. And yes, this is good news. We just sort of backed into our x-intercepts 2, 0, 6, 0 without having to factor. Now you could go factor if you wanted to like double check, but most of you are not going to do that. You're just going to roll with that, which is fine. And then I guess I could go 3, 9 if I really want to make this look nice. And domain and range. Let's see, Abigail, how about the domain? Always. Karis, how about the range? Infinity to 4 with the bracket. That's the one sometimes people mess up. I think because when your brain sees that picture, you think it starts at 4 and goes down, and that's true. But when you do the range, of course, you've got to go from bottom up, from smallest number to biggest number. All right, one more together. Why don't you try number 8? You know what? Let's do a couple things together first. So, Bella, what's A equal to in number 8?
2.
Ella, what's B equal to? And Benji, C? 24. Okay. It's tempting to want to factor out the 2, and that would be helpful when it comes time to factoring. But for x equals negative b over 2a, let's don't factor that 2 out. Let's use this b and this a and take it from there. So see how far you can get on that one.